Improving Robotics with DevOps, a presentation by Andre, Aaron, James, and Tammy. In the introduction, I'd like to go ahead and give some background to the robotics team. The team of 8 was broken into 2 smaller development teams, a hardware team and a software team. They were given a 6-month window to design, construct, troubleshoot, and refine their robotics. The goals were to design and construct the robot using approved materials and specifications, test the robot's performance to achieve optimal design, upload and interfacing software with hardware, autonomous and teleoperated robot operations, specific tasks and goals to be achieved in competition, software development and refinement of all tasks. These were the goals of the team, but as we'll see, this didn't result in exactly the way that it should have. Now that we have a little background on the robotics teams and their aims and goals and what they needed to accomplish, we're going to talk a little bit about the problems that they ran into and how, according to Conway's law, these problems can be fixed. So the process was somewhat divided. There were occasions when there was a major lack of communication between the hardware and the software teams. Sometimes the hardware team would talk about features only to find out later that the software team didn't program the feature. There was also performance configurations not communicated properly, or the hardware team would change physical environments but not let the software team know. So you can kind of see that there's a repetitive problem, and the problem is communication. And as Conway Law states, organizations which design systems are constrained to produce designs which are copies of the communication structure of these organizations. The larger an organization is, the less flexibility it has and the more pronounced the phenomenon. So even though this is a small robotics team, we, using Conway's Law, will go through and show how the communication could have changed and helped this team achieve their robotic goals and objections.
Maintaining communication can be difficult. Going back to Conway's Law, an organization produces designs which are copies of the communication structure of the organization. Since the robot group created an organization that had difficulties with communication, they were bound to create a robot that suffered from the same issues. The software and hardware teams were separate and didn't communicate well. Likewise, the robot iterations had hardware and software features that were not compatible with each other. To overcome these problems, the teams could have created both an organization and architecture that was loosely coupled. When a system is too tightly coupled, it can create interdependencies that increase the need for communication and coordination. A change in one part of the system can create conflicts in other parts of the system, and eventually it can lead to a system that can't be changed without major problems. If the team had created a loosely coupled architecture, then changes in either hardware or software would have been easier to handle, providing more time to create extra features for the robot. One reason communication was such a problem for the teams was because they were so dependent on each other. Making a change on one team created a problem for the other. Furthermore, there was very little visibility or understanding of how teams work integrated with each other. Rather than separating the different disciplines, the group could have created several feature teams that included both software and hardware developers that could work more independently from each other to add features to the robot from development to testing and implementation. Rather than strictly assigning roles to team members, effort should have been made to help each team member become a generalist. This could be accomplished by rotating people through different roles so they could gain knowledge and skills in each aspect of the project, facilitating communication and helping them understand the project as a whole.
As we have learned in the past weeks, in a technology value stream, the work is not as visible as in a manufacturing value stream because it's not entirely made of physical processes. In order to verify if the value stream is flowing smooth, or if it is piling up tasks in any point of the stream, It's necessary to make the workflow more visible. In this particular scenario, we know that there were instances of major lack of communication between the software and the hardware teams, resulting in a variety of problems, including the inability to know if any of the teams were stuck with the processing of a request. For example, if the hardware team would have known in a timely manner that the software team could not develop a suggested feature, they could have cooperated and helped each other, maybe to find an alternative feature, instead of receiving the bad news so late. So, how could our friends be more aware of the status of the work at any time? As mentioned before, one solution is to increase the visibility of the workflow. And two ways to reach this goal is by using a shared Kanban board and having a work in progress threshold. Why a shared Kanban board and a work in progress queue would be so useful in this scenario? Because the hardware team would know what tasks have been completed by the software team and vice versa. This way, for example, the software team would have known about the change in the physical environment performed by the hardware team and could have reworked the portion of the code instead of developing a full feature no longer supported. Making the work of each team visible helps to prioritize and focus on one task at a time until it's complete, or in other words, until the feature has been implemented successfully in the physical or production environment. Limiting the work in progress is strictly connected to the use of a shared Kanban board because it enhances the ideal work visibility. Each task has to be first represented in a work card, and every work center needs to have a maximum amount of tasks per time. This kind of management simplifies the detection of problems that prevents the completion of the work. So, work visibility is a key for the integration of the teams in the value stream and a smoother workflow.
As mentioned previously, one of the biggest problems that this robotics project had was that both of the teams were not communicating well, and that communication was taking longer than it ought to have. So one of the things that they could have done is have a rituals integration where both teams are part of the same DevOps rituals, like participating in the Kanban board, etc., etc. And another thing that they could have done was just simply integrate the teams so that there are dev people in the ops team and so on, and back and forth. Therefore, a faster feedback loop, meaning potential for increased productivity.
So a recap of our presentation and the solutions that we have to help this robotics team become more successful is feature groups. Rather than separating the different disciplines, the group could have created several feature teams that included both software and hardware developers that could work more independently from each other to add features to the robot from development to testing and implementation. Improved communication through making work visible. Increase the visibility of workflow by using a shared Kanban board and having a work in progress threshold. Kanban boards and stand-ups to improve feedback loop. Visibility of the entire value stream. Visibility of the tasks with high priorities. And visibility of any change. Wider DevOps rituals integration. A lot of the robotics team's issues could have been avoided if the hardware and software teams were simply one team. Faster communication means potential for increased productivity and understanding of each other's capabilities and of design vision. Therefore, we believe that if Conway's Law had been implemented, this team would have been able to meet their 6-month aims and goals by using more communication, thus sharing the knowledge and goals of the project with everybody at one time.